ARDD2022. My name is Mishal Damji, and I'm one of the ambassadors for the Inspire program. Right now I'm here with Matt Kaberlein, and I'm just going to interview a little bit about the presentation you just gave. So one of the questions I had for you is, you recognize like the NIH doesn't necessarily provide funding for a lot of these longevity pursuits, right? So your solution was to start your own company. But I was wondering, well, one solution. So I was wondering, what do you think is needed from the longevity industry in general to gain more attention from the NIH and other public institutions to not just be interested, but to actually commit like funds and whatnot?
Right. So I think there are two parts to that. One thing I would say is within the NIA, which is the branch of NIH that funds aging research, I think that the reviewers themselves tend not to fund sort of high-risk, high-reward grants. Because funding has been so tight for so long, reviewers have been trained to fund low-risk, what I would say is incremental reward grants. So that's one issue that I think we could work on. The other is, I think, the question you're asking, which is, how do we get a larger bucket of money from federal funding to come into this space? And I think that's happening gradually. I really think it's going to require both a better appreciation that the science in this field has grown into itself, and what I mean by that is that it's rigorous and reproducible. And I think it's going to require a better appreciation for the fact that the biology of aging is really the greatest risk factor for all of the diseases that NIH is focused on. So it's happening, but it's a slow process, and I think it requires continued communication by the scientists in the field to educate our colleagues who don't work on aging. And I've been really actually quite pleased to see how much progress has been made in that direction in the last few years, and how many scientists who didn't used to work on aging, may not even still think they're working on aging, are actually working on aging now.
And you also mentioned you've been in this industry for 20 years now. What advice would you give to young professionals looking to get into the space and start working on research and that kind of thing?
Yeah, well, it's not really advice, but I would say this is a great time to be coming into the field because it is expanding so rapidly, both from philanthropic funding and for-profit funding. I think that there's going to be a supply and demand problem in the near future. And what I mean by that is that there's going to be a very high demand for people who are trained in aging biology. And there just aren't that many people to fill that demand. And so I think if you're an early career investigator, a young scientist, you're interested in aging, I guess my advice would be go for it, because there's never been a better time to come into this field.
And lastly, what would you say, I know we talked about funding as one of the challenges, and one of the other challenges I've heard from other scientists is getting your papers published. But what would you say are some of the challenges besides those and the successes of the field?
So I guess I would say that one of the big challenges is that the reward system, at least in academia, has some problems associated with it. And what I mean by that is that, you know, career success depends so much on getting a high-profile publication that oftentimes high-profile publications, unfortunately, are the ones that oversimplify and leave out the complicated parts. And so I think that people often get trained to take shortcuts because it's easier to get a high-profile publication if you don't talk about the messy stuff, if you leave out the data that doesn't fit your model. And I worry that because that's the reward system, that people are incentivized to do that kind of science, which I think is ultimately counterproductive because it misleads other scientists about potentially really important parts of the story because you left it out. So that's one problem, and I tell the people in my lab to approach their research with as much skepticism as they approach the research of other people. And when you make a model, recognize that that model is wrong. Your model is an imperfect representation of reality, and your job is to go figure out how it's wrong. And I think if you approach your science from that way, you're much more likely to do rigorous work that is reproducible and also to feel good about what you've accomplished. So that's my advice.
Thank you so much for speaking to me. I really appreciate it.
Thank you.